Welcome to the public scoping meeting for the Versatile Test Reactor Project. My name is Tom O'Connor. I am the Versatile Test Reactor Program Director for the Office of Nuclear Energy. In this presentation, I will describe the mission need for the project and provide an overview of the National Environmental Policy Act and Environmental Impact Statement process. This presentation and those to follow will be available on DOE's project website at www.energy.gov/NE/versatile-test-reactor. First, we'll cover background information. The mission of the United States Department of Energy, or DOE, is to advance energy, environmental, and nuclear security of the United States, and also to promote scientific and technical innovation to further that mission. DOE's 2014 to 2018 strategic plan lays out overarching goals and objectives in support of that mission. Under strategic objective number 1, DOE will explore advanced concepts in nuclear energy that may lead to new types of reactors with further safety improvements and reduced environmental and non-proliferation concerns. In addition to supporting the development of advanced reactor technologies, the Office of Nuclear Energy is also responsible for sustaining the existing commercial nuclear power fleet and reestablishing our nuclear fuel infrastructure. Since the beginning of the nuclear age, the United States has led the world in the development of innovative nuclear technologies, developing and testing prototypes of new reactor systems and the new fuels and materials to support them. This work was led by DOE's national laboratories, working in concert with universities and industry. DOE is continuing this collaborative approach, and today dozens of commercial entities are developing advanced reactor designs that build upon the knowledge and expertise gained by early reactor development work at our national labs. These designs include both thermal and fast spectrum reactors that use their fuel more efficiently, reduce the waste handling challenges, and use coolants other than water. DOE's existing test reactor infrastructure is currently focused on thermal spectrum fuel and materials testing and does not have the capability to fully support the development of advanced reactor technologies that can provide significant safety and efficiency benefits, or the ability to conduct greatly accelerated testing of fuels and materials applicable to our existing fleet of light water reactors. Understanding that the lack of easily accessible fast spectrum capability was a serious threat to U.S. leadership in worldwide nuclear innovation and safety technologies, DOE's Independent Nuclear Energy Advisory Committee, or NEAC, surveyed the needs of the U.S. nuclear user community, which includes DOE programs, universities, and U.S. advanced reactor developers. The NEAC subcommittee's report, entitled Assessment of Missions and Requirements of New U.S. Test Reactor, was submitted to the full committee in February of 2017. It recommended moving ahead with research and planning activities to support reestablishing a fast neutron testing capability. The full NEAC committee approved that report, and DOE took action to implement its recommendations. The VTR effort is led by Idaho National Laboratory in partnership with Argonne, Los Alamos, Oak Ridge, Pacific Northwest, and Savannah River National Laboratories, as well as several key universities and industrial firms. This collaborative team has launched pre-conceptual planning studies, including the development of rough cost and schedule estimates, and evaluation of support facilities to conduct irradiation experiments of advanced fuels, materials, instruments, and sensors needed by the existing fleet and developers of advanced reactor technologies. Congress has shown bipartisan support for protecting U.S. leadership in developing new nuclear technologies. This bipartisan support is demonstrated by many major pieces of legislation in recent years, including the 2017 Nuclear Energy Innovation Capabilities Act, or NEPA, which was signed into law in 2018. NEPA directed DOE to assess the mission need for a versatile, reactor-based, fast neutron source with an aggressive schedule that would lead to facility operations as early as December 31st, 2025. DOE acted quickly to launch the VTR program in 2018 with a first-year budget of $35 million, followed by $65 million in fiscal year 2019. With the closure of EBR-2 and the fast flux test facility in the 1990s, the U.S. lost its dedicated fast neutron irradiation facilities. This capability gap, documented in the NEAC study, when combined with the legislative direction set forth in NEPA, have created the basis for the VTR program mission need. The mission need is as follows. The United States needs domestic fast neutron spectrum testing capability to test advanced nuclear fuels, materials, instruments and sensors, and prototypic environments for successful development and deployment of advanced nuclear reactor technologies. The lack of a fast neutron capability impedes DOE's mission to advance nuclear power, as described earlier, and the DOE therefore documented the capability gap as part of Critical Decision Zero, Mission Need, that was approved by Deputy Secretary of Energy Dan Briette on February 22, 2019. In support of the VTR project, DOE is preparing the VTR Environmental Impact Statement, or EIS, as was required by the National Environmental Policy Act, or NEPA. NEPA and its implementing regulations require federal agencies, like DOE, to consider the potential environmental impacts prior to undertaking a major federal action. Within DOE, the environmental impact statement is required for the construction of a new reactor, such as VTR, and is prepared early in the lifetime of the project prior to taking actions that could limit the selection of an alternative. The EIS process serves to inform the public about the project and allows the public input. This scoping meeting serves both of these purposes. The mission need discussed previously is translated into an EIS purpose and need. The EIS evaluates reasonable alternatives, including one or more action alternatives that meet the purpose and need, and a no-action alternative. In addition, the EIS provides the rationale for alternatives that were considered but not evaluated in detail. An EIS describes the existing environment at the candidate sites and evaluates the potential environmental consequences of implementing the project at those sites. If needed, the EIS identifies mitigation measures to reduce impacts to acceptable levels. An EIS also evaluates cumulative impacts, which are the environmental effects of past, present, and reasonably foreseeable future actions when added to the proposed action. DOE's purpose and need for taking this action is to provide a domestic, versatile, reactor-based fast neutron source and associated facilities that meet known requirements. For example, a neutron flux of at least 4 times 10 to the 15th neutrons per square centimeter per second. The associated facilities include those for the preparation of driver fuel, in other words, the fuel that powers the reactor. Other facility needs include the ability to fabricate experimental fuel and material specimens, the fabrication of experimental sample holders and test rigs, as well as facilities to perform post-irradiation examinations. As noted previously, with the closure of EBR-2 and the fast flux test facility, the U.S. has not had a viable domestic fast neutron testing capability for over 2 decades. DOE needs to develop this capability to establish U.S. testing infrastructure for the next generation of nuclear reactors. VTR will help us develop the fuels, materials, and instrumentation that will enable nuclear energy to expand its role beyond just electricity production. VTR will give us the fast neutron flux needed to conduct accelerated testing to support rapid development of innovative technologies. VTR will help the United States regain and sustain our global leadership in this emerging technology space, which is essential to protecting our interests along with those of our allies when it comes to nuclear safety, security, and non-proliferation. As you can see, The lack of a versatile fast neutron testing capability is a significant strategic risk affecting the ability of DOE to fulfill its mission to advance the energy, environmental, and nuclear security of the U.S. and promote scientific and technological innovation. The proposed action is for DOE to construct and operate the VTR at a suitable DOE site. DOE would use existing or expanded, co-located post-irradiation examination capabilities as necessary to accomplish the mission. DOE would use expanded existing facility capabilities as necessary to most efficiently accomplish the VTR mission. These existing or expanded capabilities would be used to fabricate VTR fuel, testing items, and manage radioactive wastes and spent nuclear fuel. Executing the proposed action on such an aggressive timeline will require a strategic approach to avoid first-of-a-kind challenges with new facilities. It will require the selection of a proven technology with a high degree of technology readiness and extensive operating experience. It will require leveraging existing technology to significantly reduce the design time and avoid the development of new fuels, which can take decades. It will require establishment of a well-integrated design and construction schedule so that nothing is left to chance. The alternatives under consideration for the draft EIS are as follows. Under the Idaho National Laboratory VTR alternative, the VTR reactor would be sited adjacent to INL's Materials and Fuels Complex and would make use of the existing inert hot cells and other MFC facilities for post-irradiation examination. Many of these support facilities were originally designed and built to support the operation of EBR-2, which was also a sodium-cooled fast reactor. Under the Oak Ridge National Laboratory VTR alternative, the VTR reactor would be sited at an ORNL location to be identified and would use existing ORNL facilities to support post-irradiation examinations. Under the no alternative action, as required by NEPA, DOE will evaluate a no-action alternative and not build a VTR. This alternative would not meet the purpose and need. In regards to the fabrication of the fuel needed to run VTR, consideration is being given to locating these facilities at Savannah River Site and INL, and depends on a number of factors including the source of the nuclear fuel material, condition of the proposed fabrication facilities, and security requirements. As required by NEPA, DOE has identified several areas of potential environmental impacts. These areas will be thoroughly evaluated in the EIS. On this slide, we identify resource areas associated with the physical site and natural environment. The EIS will evaluate potential impacts on air, water, biological resources, the land itself, and cultural resources. Here we identify resource areas as related to human environment. The EIS will evaluate potential impacts on land use, human health, and socioeconomics. The potential for disproportionately high and adverse effects on minority and low-income populations, and effects on waste management systems. Again, the main purpose of this scoping meeting is to receive public input on these identified resource areas and whether there are other areas DOE should consider as the EIS is prepared. An EIS is prepared to inform DOE decision makers and the public about the environmental impacts of the proposed action and reasonable alternatives. The EIS process is designed to involve the public and includes opportunities for public comment at scoping meetings and public hearings. The scoping period for this VTR EIS is 30 days. The minimum comment period on the draft EIS will be 45 days as required by regulation. The EIS process also engages other agencies through consultations on required topics such as threatened and endangered plants and animals and cultural resources. At the conclusion of the EIS process, DOE's selection of an alternative to be implemented is announced in a record of decision. As stated earlier, the 30-day scoping period is being conducted to allow public comments on the scope of the VTR EIS. The scoping period began on August 5, 2019, and is scheduled to end on September 4, 2019. As part of the scoping process, we are holding these two webcast meetings on August 27th and 28th. After these presentations, there will be an opportunity for the public to provide their comments on the scope of the EIS. All comments received during the scoping period will be considered as we finalize the scope of the VTR EIS. To provide your input on the alternatives or potential impact areas that should be considered, the contact information for submitting comments in written or electronic form are shown on the screen. Comments can be submitted by email, addressed to vtr.eis@nuclear.energy.gov. Alternatively, comments can be submitted by U.S. mail addressed to VTR EIS Document Manager. That address is Gordon McClellan, Document Manager, U.S. Department of Energy, Idaho Operations Office, 1955 Fremont Avenue, Mail Stop 1235, Idaho Falls, Idaho, zip code 83415. Any question about DOE's NEPA process can be addressed to the NEPA Compliance Officer, Jason Sturm, at vtr.eis@nuclear.energy.gov. If you'd like to be added to or removed from the distribution list, those requests should also be addressed to vtr.eis@nuclear.energy.gov. Links to the Notice of Intent, all of the presentations used for this meeting, and extensive background information will be posted on the VTR website at www.energy.gov/ne/versatile-test-reactor. As DOE proceeds with the EIS process, additional materials, including the draft EIS, will also be linked on the VTR website. The Notice of Intent and draft EIS will also be available at www.energy.gov/NEPA. As we described earlier, VTR is essential for U.S. to regain a global leadership role in the development of next generation of advanced reactors and to revive and revitalize our nuclear industry. Failing to lead in this area yields worldwide leadership in nuclear technology and innovation to other nations, and this represents a strategic risk in terms of economics, the environment, and geopolitics that would adversely impact the long-term interests of the U.S. and her allies. DOE expects to issue the draft EIS as early as the summer of 2020. Issuance of the draft EIS will start a 45-day comment period during which DOE will hold public hearings. As with the current scoping period, comments will be accepted at public hearings and by mail and email. DOE will consider all comments received on the draft EIS in preparing the final VTR EIS. DOE expects to publish the final VTR EIS as early as the summer of 2021. DOE will announce its decision regarding the VTR and publish a record of decision in the Federal Register no sooner than 30 days after issuance of the final EIS. Following are 3 presentations intended to help you understand what the versatile test reactor is. The first presents the differences between a power and test reactors. The next presentation discusses the versatile test reactor and investing in the future of nuclear energy. And the final presentation provides a virtual tour of the versatile test reactor concept. Thank you for your attention.